who thinks creativity is important in innovation? Most people, right? So I'm going to do a scientific experiment now. I'm going to ask you in a minute to hold up 2 hands. And on a scale from 0 to 10, I want you to tell me how good you were at painting when you were in kindergarten. Okay, ready? Now hold up your hands. How good were you at painting? 10 is really good, and 0 is not very good. So people seem to be pretty good, all right? Now, today, how good are you at painting? Hold up your hands. See, an average is more like 5, right? So what happened that turned you from an 8 painter in kindergarten to a 4 or 5 painter today? Somehow our system takes creativity and sort of beats it away through obedience school or through risk adverseness or whatever it is. And so there's something about the way we raise ourselves and become adults that takes creativity out of the way we think, the way we live. And I think what's really important today is as the world continues to change aggressively, you need to continue to innovate, which means you need to continue to learn, which means you need to continue to be creative. And Robinson and a lot of other people talk about this in the framework of education. But I think what's really important is that there is a way to try to stay creative as you become an adult. And we have a group at the Media Lab called Lifelong Kindergarten, because we believe that the way that you learn in kindergarten, which is messing around and tinkering and figuring out what you need to do in order to play the way you want to play, is actually a great way to learn. And the somewhat sort of mass-produced industrial revolution system of education may be okay for certain types of learning, but really is suboptimal for creative learning. And so the Media Lab is a very unique institution in higher education because we are all about being like a big kindergarten, and I'll try to explain a little bit of that. But before I go there, I want to describe, are the slides up? Let's see, can I get, there we go. So first of all, I think the internet is the single most important thing that's happened to us. And I think it's so important that it actually is part of this affect our evolution. And so I divide the world into 2 sort of eras. Before internet, when life was kind of simple, and Newton's laws worked. So, if you use a physics metaphor, Newton's laws, when things are approximately a simple size, moving at simple speeds, you can measure trajectories, you can predict what's going to happen. But when you increase the complexity, like we have with the internet, make things huge or small or fast, suddenly Newton's laws, you find out, are just local ordinances, and that there are many, many other laws that come into play. And we don't yet understand all of the laws of physics to be able to predict everything that happens. And similarly, in the AI, after internet age, we really don't yet know exactly how to predict or understand how things happen. And maybe there is no way to predict how things happen. And so what's really important is to think about how innovation worked before the internet, how it works after the internet, and how we need to change the way we live because we are now in the AI world. So this is just an example because this is a personal example. I helped set up the first commercial internet service provider in Japan. And back in the day, we were competing with actually the predecessor to ITU. But basically, big companies would send these button-down, necktie-wearing, very smart experts to these intergovernmental agencies, and they'd sit around for years and years and sort of discuss every possible problem, every possible opportunity, and they would create these massive specifications that were literally, hundreds and hundreds of pages. And no student, no single small group of people could ever get their head around these specs because they were so complicated. So the large contractors and the R&D labs, like the Bell Labs or the NTTs, would render these humongous specs into products and services that we use, like the 3G phones that we use, and they go back and feed this big machine with taxes and services, and it went round and around. And this was okay when the cost of failure was really, really high and you couldn't change things later. But it turns out with the internet that you can change things later because it's mostly software. So the way we designed the internet was, it was flat. We had companies and governments and 12-year-olds all working on the internet together, and it was very much a sort of bottom-up distributed innovation system. And what's really important here is not just the technology of the internet. This is centralized, controlled innovation. This is chaotic, distributed, almost an anarchy system. And as you all know, the internet won. And why this is tremendously important is this is the first time on a massive scale that distributed innovation beat centralized planning, right? And this is why the internet is a philosophy and not a technology. And that internet philosophy is also turns out to be the same DNA as the Media Lab. This is my toilet. This is also the first commercial internet service provider in Japan. And for a couple of $1,000s, actually $1,500, I bought a Sun Spark Plus off of Usenet, and we put together a bunch of different things. And it would have cost a telephone company millions and millions of dollars to deploy what they would be able to call a point of presence. But because the internet was all about anything that works doesn't have to be licensed, you had the freedom to connect, the freedom to hack, and you actually didn't need all of this extra stuff. You could throw it together. And this, if you think about this, this lowered the cost of innovation tremendously, because the cost to set up the first commercial internet service provider in Japan was the rent for my toilet and a couple $1,000s worth of used Cisco and Sun equipment, and we were up and running, right? And this is, I'm going to jump to a slightly different topic, but related. This is a slide from one of our faculty at the Media Lab, Cesar Hidalgo. And the vertical axis is sort of the total amount of knowledge in the world, and the horizontal axis is time. And in the early days, sort of BI, if you look at the picture, making a spear, you could probably fit all of the information necessary to design and build a spear in the head of a single individual. But as the world got more complex, you had to divide the labor because you couldn't fit all the information necessary to create a product in the head of an individual. So we had to create firms and organizations, and they had to share within the organization and collaborate. But today what's happening is the normal objects that we create, the things that we work on, are so complex that they exceed the cognitive limit of an organization. So if you think of a company, doubling the number of the people that work at IBM doesn't double the amount of complexity IBM understands. IBM now has to work with a lot of other companies. And so this is really an important shift that's happening in society, because companies now need to share and work together a lot more. And this is David Weinberger, who's here, I think, but he has a great book, and I like the title more than anything else about the book. But it's a great book. But the title is super important, because small pieces loosely joined is how the internet works. If you think about every single important thing that has happened on the internet, it's always been a small group, usually students, whether it's the first web server or whether it's Yahoo, Google, all of the specs, they're all designed by small groups of people, loosely connected by standards that we've agreed on. And again, if you think about it, if you compare these big government standards that you had to carry around in boxes, internet standards are like 2 or 3 pages long. They're called RFCs. Stands for Request for Comment, which is very humble. And so these RFCs connect these pieces together, and no one tries to control the internet. No one knows the whole of it. You create a product. I'm an investor in Twitter, and I remember in the early days when people started using hashtags, we were like, oh, wow, that kind of sucks. It wasn't really what we designed, but if everybody wants to do it, let's iterate that way. And the idea is that you should sort of celebrate when your tool is used in a way that you didn't want it to be or anticipate it to be. Whereas in the old days, you would be thrown in jail if you used a tool in the way that wasn't designed. And I'm going to add another graph that everybody knows. This is Moore's law, so everybody knows this. Speed of the computer is doubling every 18 months. And if you add that all together, the fact that we have a low-cost internet that allows collaboration and distribution at almost no cost, and you have computing power going down incredibly, what it means is you've got a low cost of innovation. And so what does that mean? That fundamentally changes. So for instance, my day job used to be venture capital. So in the old days, you'd write a business plan, you'd raise the money, you hire the guys, and build the thing. Today, if you think about Yahoo, Google, Facebook, you build the thing, then you raise the money, then you figure out what you're doing, right? And it's completely opposite, right? It's build first, money second, think later, right? And that's fine, because the point is, and at the Media Lab, we call it practice over theory, right? If it works and you've got traction, you can raise the money. And by the way, if you think about where the MBA is in this chain, the MBA used to come first, now the MBA comes last, right? So who should be thinking about innovation is actually should be the kids who build stuff. And this also fundamentally changes the nature of risk. So this, now that I'm in academia, I have to qualify this. This is not a scientifically valid chart, think of this as what the brain of a big company executive looks like. So a big company executive is going to be worried a lot about downside risk. They're going to be worried about budget overruns and the market, all kinds of things you can do to completely screw up your company. There are upside opportunities, but it's little margin here, little market share there. Very, very difficult to get exponential growth on upside. This is what a VC's brain looks like. So my average investment has been about $100,000 per company. So the most money, if I gave John Gage $100,000 to set up a company, the most money I will ever lose is $100,000. So if John calls me up, and this happens frequently, it happened actually last week, entrepreneur calls me up, says, my business isn't working, help me out, help me raise money, help me figure out what I need to do. And I say, shut down the company, do something else, you're a good entrepreneur. Because my time to figure out what he's doing, help him raise money is going to be more than $100,000. And I remember when I was setting up that silly ISP I was showing you, I was trying to raise money from a big Japanese trading company. I wanted $600,000, and they set up a feasibility study corporation and spent $3 million to decide not to give me $600,000. And this is really the kind of irony that we have today, because most companies, the average minimum viable product sort of to set up a service on the internet probably costs $30,000. The average investment committee meeting cost of a VC is hundreds of thousands of dollars. So a lot of VCs are now starting to do these funds that just give money to good entrepreneurs without reading a business plan, without really getting their head around what's going on. And if you go to the very right, if you put $100,000 in Facebook in the first round, it'd probably be worth about $1 billion today. And every single fund that's successful has one knockout home run that pays for every failure in the fund. So you don't sit and try to double every investment in your fund. You try to at least knock one out of the park. You swing for the fences. But you don't really know which ones it's going to be. Like my favorite companies that I thought were going to be successful often aren't, and it's usually the ones that you don't expect. If you talk to a VC, it's the one that they almost didn't invest in, or the one that didn't fit the investment thesis are usually the ones that are home runs. And the ones that are right in the investment thesis and look like they're going to be home runs usually end up being the two-bagger, three-baggers. So really, when the cost of innovation is nearly zero, it's much better to bet where you can. And then when you get a good company that's going well, you double down. You help them. If you're the investor in Google, they stuck Google into Yahoo. And that was a lot of the VCs, and that probably doubled or tripled the value of Google very quickly. So you really, this is the way you think. You look for opportunities. David Clark, who's at MIT, he was one of the first architects of the internet. He has this term, rough consensus running code. And this is the internet philosophy, but this is also the philosophy of agile computing, lean startups. It's really build it first and then just figure it out as you go along. And it's tremendously important for agility. And agility is really important because, for instance, I don't know if any of you used YouTube in 2005, but the default was, I am male seeking everyone between 18 and 45 upload video. It was a video dating site, right? It didn't work. And so they pivoted and said, we're going to become Flickr for video. That was when I talked to them. And I said, I don't know about that. And then they found MySpace, and they became the video embed tool for MySpace, and they just took off. If you think about, and I've been in engineering meetings at companies where we do weekly sprints. So every week we push new features. And the engineers will sit there and cry when we say we're going to dump that feature because they've spent the whole week working on it. But they'll still listen to us. Imagine if you had spent 2 years and 1 million lines of code and 100 patents. You're not going to change course, even if you're a dating site for video. You're going to say, we're going to stick this out for a couple more years. But the fact is, when you're a startup and you've got a couple kids and you're running and you jump out the gate and everyone says, you pivot very quickly. And what's really important about pivoting and agility is all of those things that we think of as assets, lines of code, intellectual property, are actually liabilities when you think about it in the context of agility. And today, a very famous CEO that I know once said, we don't do strategy, because by the time you figure out a strategy, the world has changed. And really what robustness today, especially in the internet, is about how agile you are and how resilient you are, and not about whether you have a strategy or a plan. And think for yourself and question authority. We'll talk more about this later. And we have John Silly Brown here. But he uses the term the power of pull, which again has a lot to do with agility. You don't stock information and centrally push it out to the edges. What you do is you pull the information as you need it. And now that I'm an academic, or not, I'm not an academic, I manage academics. you think about academia, you pile all this information into someone's brain as if they're going to be going up some mountain and have no access to internet and no friends and how to survive, when really today what you're doing is you sit around and you collaborate and you pull the information as you need it, because do you want to read a 10-year-old programming manual? No. Then why are you teaching kids how to program 10 years before they're going to use it? And I think the idea is you don't want to stock all this stuff because it's going to get old and you may not need it. And really what we need to be teaching is the power of pull. How do you pull the resources that you need? How do you get people to collaborate with you? How do you cheat? And it turns out, by the way, there's a funny study. The kids who cheated on tests retained the information better than the ones who got it right. Just so you know. Another important thing is embracing serendipity, because you kind of got to get lucky, right? And we can talk more about this later, but I think what's really important is the Media Lab for me is kind of like a serendipity engine. And pattern recognition is also really important. So pattern recognition, I don't know, are there any mushroom hunters in the room? I got a couple mushroom hunters. When I was talking to a bunch of people from Northern Europe, everybody was a mushroom hunter. But when you do mushroom hunting, it's really important. The people who have done it probably know, is you don't focus. You unfocus, and then the mushrooms pop up. This is the same as if you're a hunter, an archer, for instance. When you focus, you're actually only focusing on about 1% of your field of view, and everything else is being cognitively filled in for you. And so to get peripheral vision, you actually have to unfocus. There's a study that shows that if you put a dot in a screen and you put colors around the periphery, you can watch the dot and you'll see the colors. If the minute you give somebody a financial reward, you say, I'll give you $10 to watch the dot, everything on the periphery disappears. So most of our lives, we plan and we focus and we tell people, focus is so important, execution is so important. Well, that just means you have no peripheral vision. And in a disruptive world where most of your damage comes from disruptive things that you are in your periphery, and in most of your opportunities and serendipity, because you can't have serendipity if you're not looking around, right? And so to me, pattern recognition and serendipity is really important. Since I don't have a lot of time, I'm going to zip through this because I think this is an interesting example of the power of pull. So Safecast is a startup, a nonprofit that I started March 11th. I don't know if you remember, but that's the earthquake in Japan. I happened to be visiting MIT for the first time. And so I got a bunch of people together because my wife was in Japan and was worried about the radiation. So we got some hackers together working on hardware. And then we pulled in all kinds of people. We were able to find the guy who did the 3 Mile Island Geiger counter sensor network, and some web kids, and some people from IDEO, and some hacker spaces, and Bunny Huang, who's a Media Lab alum, and a bunch of kids from the Media Lab joined in. And within weeks, we had probably the best expert network of hardware people, sensor people, data people. Reyazi jumped in to help us with the data structures, and we suddenly had this ad hoc team going from not knowing anything about radiation measurements to probably the best team in the world on radiation measurements in a week. And then we realized we didn't have enough Geiger counters because the sensors were in short supply. So we built the bento box size B-Geigy that we put on cars, and we drove around and started collecting data. And Tesla lent us cars, which was great. And we had all these volunteers come together, and Tony at the Media Lab started working on the visualization. It turns out we learned a lot because the government was sending people in to measure these places, but they weren't sharing the data with the citizens. And we found that even in the same town, you get 10 times different measurements in some places. Some people were being evacuated from places that had lower radiation to higher radiation, and we were able to collect a lot of data. And for a while, the government hated us, but now they are starting to like us. We've got lots of measurements. We've got the largest data set of radiation data in the world now. And we also realized that Geiger counters don't get redesigned very often, only in these sorts of periods. So Bunny, who's a Media Lab alum, designed one of the coolest Geiger counters in the world. And we open hardware license. So anyone can now download this Geiger counter and build it. And it's now being built in volume. We just did a Kickstarter and raised, I think, $100,000 to distribute these new Geiger counters. And because the specs are open, people are making Geiger counter synthesizers, and so on. And I'm going to pivot now back to the Media Lab. So this is it's a multi-function CNC machine. So this does cutting, milling, and 3D printing, and it's on a desktop. And the work we're doing at the Center for Bits and Atoms and all over the world in the fab business, what's happening, I was talking about earlier about lowering the cost of innovation in software, pushed the innovation out from the labs to the periphery, is now happening in hardware because the cost of innovation in hardware is now going down at the same rate. And almost crazy, but actually happening, is biofab. So we now have Joe Jacobson in our lab, who is now able to, so I don't know if you guys know, but like people, when we print genes, when we fabricate genes, it's done by hand right now. So you end up with about 1 in 100. When you get a base pair of about 100, you start getting real errors. And in the old days, the limit of the complexity of a machine was that the number of transistors that people could wire by hand was like 200 or 300. And so when the IC came, that started Moore's law. Well, now that we have chips and microarrays creating genes, and we can fabricate genes, the amount of complexity that we can design into a gene is going to go up with Moore's law, and hopefully we'll be able to do things like grow the tree in Avatar and design a house that actually grows itself. And so all of this means that as these technologies hit Moore's law, it lowers the cost of innovation, pushes the innovations to the edges, and allows students like the kids at the Media Lab to do the kind of world-changing innovations without hundreds of millions of dollars and big government grants. And so these are kind of our 9 principles, and since I'm running out of time, I'll just skip a few of them. And also, my faculty don't agree on this. These are mine. But you know, I think disobedience is important. This is sort of Timothy Leary's question authority and think for yourself. You never win a Nobel Prize by doing as you're told. You know, practice over theory. There are a lot of universities economists who have theories, and when they do a test, and the test doesn't come out the way they want, they question reality. We think reality is more real, and we come up with a theory later. The cost of mapping exceeds the cost of trying, but it's important to have compasses and things like that. And so the Media Lab is Media Arts and Science, and I'm going to pass it over to the kids from the lab soon. I think the key thing about the Media Lab is a very open sort of atelier model where it really is about building things. We don't sit around and talk about things. Some people have scholarship, but scholarship isn't really emphasized. It's really about build stuff and learn as you build it. It's anti-disciplinary. We've got 26 faculty, 140 grad students, probably about 400 scientists in the total ecosystem. But the key thing is this is undirected research funds. So they don't tell us, the 75 companies don't tell us what to do, and I don't tell my faculty what to do, and the faculty sometimes tell the students what to do. We have a huge variety of groups, ranging from opera to synthetic molecular biology to robots to biomechatronics. And the key really is that for every faculty and for every student, if you could do what you wanted to do somewhere else, you don't belong at the Media Lab. The Media Lab is only for misfits, because this is really where we're trying to do things that no one else can do. The 3 criteria for a good project are impact, uniqueness, and magic. And if we don't hit those, it doesn't really work for us. So we just did a faculty search where we use the word anti-disciplinary. If you fit in a discipline, you don't fit in the Media Lab. The Media Lab was designed before we had the internet. So a couple of changes that we're making is we're trying to change it from a container to a platform. And less focus on products, more focus on ecosystems. Change the name. We don't call people sponsors anymore. We call them members. It's a membership organization. Members talk to each other, and the value of the network is very important. So we're going to call it the Media Lab Network. And this is the announcement that was sort of in the description of the talk. We're launching the Innovators Guild. And what that is I've met a lot of chief innovation officers, and they're kind of lonely in their organizations because they're given this sort of impossible task. The good thing is they're usually not in the line of business, so they don't have a lot of IP issues. But they really want to share information. So we try to create a guild for chief innovation officers. And the first thing, and we're going to build that system together with IDEO, but one of the key elements of this Chief Innovators Guild is we're going to focus on doing things. So the idea is to try to deprogram people from this need of risk-averse planning that people do in companies. So the first thing we're going to do is work together with the Knight Foundation to go to downtown Detroit with a bunch of chief innovation officers, a bunch of students and faculty, and the local community in Detroit, and probably build an urban farm. And it's sort of a mix between Outward Bound, a hackathon, and sort of a crazy party. So we'll be documenting this, and we'll be announcing more later. The Innovators Guild will be a longer-term club. And do you know what the email address is that we're sending it to? So we'll be blogging on the Aspen Ideas Festival, but if you're interested in the Guild, please send us an email. And with that, I will hand it over to my awesome students to do their demos. Thanks.
All right, so hi everybody, thanks a lot, Joey. My name is Ben Waber. I actually got my PhD from the Media Lab in the Human Dynamics group. I'm also a senior researcher over at Harvard Business School, and I actually started a company based on my research. So I'm actually going to start maybe in a weird place when you think about the Media Lab. You probably don't think very much about organizations and management. And that's really what I'm interested in. I'm really interested in how can we use technology to make people work more effectively. And when I think about this problem, when I think about how people work, I actually think a lot in environments like this. And you might question, well, why should we even think about these ancient environments? And I would argue that for most of human history, for hundreds of thousands of years, people worked in environments like this. And you lived in these environments. Well, and in 10,000 years ago, when you were working, you were hunting, you were gathering. But what this means is that these sort of environments, the people that you were working with, you got to know them very, very well. So you understood small changes in facial expression. You understood small changes in the way that people spoke. So it's very easy for you to communicate very quickly, very complex information. And then you think about how we work today. And it's a little different, right? This is something where a lot of us are familiar with workplaces like this, where you certainly don't live with the people you work with. And it's also something where we just don't spend a lot of time with them. A lot of times we think we're being most effective when our noses are down at our desk and we're not talking to other people. But I sort of wonder, are those ancient behaviors still manifested in this sort of environment? And are there small ways we can change these environments to understand, to sort of create environments that are much more effective for people? And I think that one of the issues is that it's just very difficult to measure these ancient behavioral patterns. And I think when you take this perspective on these ancient behaviors, you get an interesting view about many organizational problems. For example, why is organizational change hard? Why is M&A hard? And that might seem like a really silly problem, right? Or reorganization is just very hard. Mergers and acquisitions is just hard. But think about that for a second. I mean, M&A, you have companies, big companies all over the world doing the exact same thing, very smart people working on these problems, and it still fails about 60% of the time. It destroys roughly $1 trillion in value a year. I mean, that's incredible, right? There's clearly something that we're thinking about wrong. When people are thinking about mergers and acquisitions, you're typically thinking about financials. You're looking at the formal organizational structure. You're not thinking about what are the culture of these two organizations. How can I really get people to collaborate with each other? How can I socially integrate this new organization with the existing organization? And again, when you think about these informal things, you can start to think that maybe those are really important, but we don't really have a good way to measure them. Previously, a lot of social scientists, consulting companies, have used they use surveys, they use human observers, but we know there's lots of problems with that. With surveys, for example, if I asked you who you talked to yesterday, you'd be really bad at answering that question. You basically just tell me people you like, you tell me about people you normally talk to, which has absolutely no relevance to who you talked to yesterday. And with human observers, yeah, I can follow around one person for a month, even though it's a little creepy. But if I wanted to observe 1 million people continuously for years, you can't do that using any traditional techniques. So what we've done is we've actually used sensor technology. What we've done is created a wearable sensor badge that you can think of as a replacement for a company ID badge. Company ID badges today already have a little RFID chip in them, so you can tap into walls and you can enter new offices. But what we've done is add additional sensors to that. So now we don't just know location, but we can look at who you're talking to and how you're talking to them and do some really interesting things with that sort of data. And the reason we come at it from this perspective in the Media Lab is we actually used to be the wearable computing group. And so back in the late 90s, we were making these big wearable sensor vests with big batteries on the back that heated up a little bit too much. But over the course of time, these sensors get smaller and cheaper and faster. And then finally, we can get to something which is actually the size of a regular ID badge. And so I'll talk a little bit about what we have in this badge. So the first sensor we have is we have a little microphone on the top, which actually in real time does voice analysis. So it's not actually recording what you're saying, but in real time what it's doing is looking at your tone of voice, your volume, how quickly you're speaking. We've done a lot of controlled studies to connect those features to things like persuasiveness, interest level, and boredom. We combine that with data from an infrared transceiver, which if you use a remote control, you've used an infrared transceiver. So just line of sight communication. So if I'm facing you and you're facing me, I can actually detect that we're facing each other. And there's a lot of psychological properties that you can imagine you can actually back out from that. For example, do people tend to face you more than you face them? Combine that with data from Bluetooth, which again is also a sensor. So by doing a Bluetooth scan right now, I could figure out who's close to me, how far other people are from me, and by putting up little base stations in companies, I can figure out approximately where people are. We combine that with an accelerometer, we can actually look at your posture, your motion as well. So I just do want to point out that we actually don't go into companies and just say, here, wear this, right? Because I wouldn't do that. But what we do is we actually do opt-in. And so people can say whether or not they want to participate. We even give people fake badges if they really don't want their boss to know they're participating, because companies don't get individual data. But we get, by and large, we get well over 90% participation in most of the projects we do, simply because people really care about their interactions with other people and want to understand really what's going on at the company, because at the end of the day, people just don't know what's going on. And so I'm just going to show you an example here. This is from one of the projects we did at a German bank. And what you see on the bottom is email between different teams, and on top you see face-to-face. You'll notice, actually, if you look at face-to-face, no one talks to customer service at all. But what they're doing here is developing a new financial product. And when they release the product, there's actually a lot of incorrect information. And that's when they go and talk to customer service and all of a sudden bring them in and ask them to help fix the problem right there. So it's something we're even just seeing who's talking to who. Companies didn't even know that this was going on. And we showed this to management. They're like, if we'd seen this before, we would have brought them in earlier. So this is very basic. We're not even doing analysis here. We did do analysis, though, when we worked with Bank of America in their call center operation, which is very interesting because call centers, you traditionally think that interaction is not important. But what we did is we did this in two phases. The first phase, we actually showed how people were communicating and how these patterns were related to outcomes like productivity and stress levels. Then we changed the way they worked, and we saw what happened. The first phase, what we saw was that the more cohesive your face-to-face group was, the more productive you were. It was a very strong effect. That predicted about 2/3 of the variance in terms of performance. So cohesion, we looked at who did you talk to, and how much did those people talk to each other, so all sensed. We also saw that people with more cohesive groups were much less stressed. So again, if you have this tightly knit group, it's a very stressful job working in a call center, you were able to sort of complain a little bit more to those people. So all we did is we changed when they took breaks. We actually saw that 80% of the interaction was happening when their lunch breaks would overlap, because typically in call centers, people don't have breaks at the same time. So this is all we did. For these teams, we gave people breaks at the same time. And then we came back 3 months later, so it was normal practice, and we said, what happened? So this is what happened. We measured with the badges again. We saw that the groups were about 28% more cohesive, which you would expect because now you have more opportunities to interact. Stress went down very significantly. We measured that through the badges, but we also collected survey data. And productivity went up by about 25%. And this is hard numbers, right? This is how long did it take people to complete calls. And so the bank would save millions of dollars if they rolled this out across all their call centers. And what was really interesting here is traditionally when you go to a company and say, we're going to increase everyone's performance by 25%, the normal reaction is like, wow, we have to change everything. And what these results are saying is that actually, if you can find the social levers that people are responsive to, and you can act on them in the right way, you can get really big results. And that sensing technology is the way to get to that point. So we started a company around this called Sociometric Solutions that does this commercially. And yeah, we've still been doing a lot of research in the lab. So it's been fantastic, and thanks a lot for listening.
Hi. So my name is Coco. I'm in the Human Dynamics group, the same group as Ben at the Media Lab, and I'm working on my PhD. So Ben talked about how the sensor technology can be used to measure human interaction dynamics at the scale of a company or an office. And I'm going to talk about using so-called big data to measure how people change at the population level. So I'll start with this visualization by E.J. Murray. He's the French inventor of chronophotography. And it's a visualization of 19th century French train schedules. So you see, I think the axis is a little blocked out, but you see on the left how the schedule of trains from Lyon to Dijon to Paris. But behind each of these lines is sort of the daily patterns of many thousands of travelers who day in and day out conform to certain patterns. And I've been using a more modern sensor, actually tens of thousands of anonymized credit card records, to look at how people change over time, how they move around, and how habits form and break. So I have 3 sort of small points today. The first is that in most of what we do, we're driven by habits, that is, repeated behaviors. The second is that the amount of time we spend exploring predicts how quickly our habits change, and this is not a really intuitive finding. And the third is that there are statistical regularities that define our habits. But at short time scales, it's nearly impossible to predict where an individual will go next, which is sort of good news for those of us who still believe in privacy or free will. So the first result is that repetition is the basis of almost everything we do. How long have you been at your current job? How often do you go to the same grocery store? How many times have you paid your same utility company? So all these things are repeated patterns. And I'm able to show that across thousands of people and location, the more frequently you do something, the more likely you are to keep doing that for a longer period of time. The second point is that the more we explore, the more we change. So the rate of change in a portfolio of places that any person visits can be modeled very well by a process of random drift, where trying something new is akin to sort of introducing a mutation, which with some probability will percolate up into a habit. So this is sort of a cartoon graph where each dot represents real data, and it stands for a few hundred individuals. And it shows the linear relationship between the number or the number of new locations we explore and the rate at which we change, the rate of drift in a portfolio of stores. So this holds for the most frequented stores. These are sort of the most habitual locations we go to. But if you start looking at things that are sort of lower down the ranks, you see something interesting, which is that the effect of exploration begins to saturate. And in that second regime on the right, we seem to be just exploring for novelty's sake, just for fun. It's not to optimize where we're going, to find better and cheaper and more convenient locations, but simply out of a taste for novelty. And so it's not surprising, perhaps, that when you split this down by income level, you see more lower income people on the left and more higher income people on the right. So that is, if you're in a higher income group, you have the luxury to explore simply out of fun, not to optimize anything in sort of the traditional economic sense. So these are sort of the aggregate patterns, but with all this big data, can we actually predict where someone will go next? And the short and perhaps relieving answer is no, not really. We're good at predicting behavior at a coarse-grained level, but it's nearly impossible to robustly predict where a single person will go next. So this chart shows how predictability decreases as you add more days. So it's using an information entropic measure, and as you aggregate over a longer period of time, the entropy goes down and the predictability goes up. So very slowly at first, but basically what this chart is saying is that at a weekly level, we interleave and we change our patterns very frequently, but if you start looking at people over longer time scales, they actually start seeing these patterns emerge. And we built a number of models to sort of say, what's the best way of figuring out where somebody will go next, how they'll sort of chart their day. And what we find is that the best way, or one of the best ways to predict where somebody will go, is to figure out where they go most often. So building these more complicated models with transition probabilities actually doesn't really do any better. And the best model, actually, the best class of models at the top, is to take in social information to figure out where people like them tend to go next, and that actually increases the accuracy so much. So you may be wondering what this says about sort of practical habits. How do you encourage your kids, or perhaps in your case, yourself or your spouse, to eat more Brussels sprouts? So there's a lot of research that has shown that as you do something more often, the automaticity with which you do it increases, and this sort of leads to forming habits. So I'll just end with one of my favorite experiments. It did not come out of the Media Lab. It was in fact done in the 19th century, and I think I like this experiment so much because it's of a nature that for various legal, ethical, and common sense reasons could not really be replicated today. But in a 19th century British orphanage, it passed muster. So here every child was allowed in the orphanage was given a list of various food items, and they were allowed to pick for each meal any combination with no restrictions of these various items. And so the researchers left, and they came back a couple months later, and they found that each child had picked his own sort of unique combination of foods for breakfast, lunch, and dinner, and none of them really overlapped. They were all very different and unique. But that each child stuck very vehemently and forcefully to whatever combination he'd elected. For example, one kid really liked to eat liver, bananas, and eggs together for breakfast. So I'll just leave on that note, and end with the idea that at the small scale we are unpredictable. At the large scale we're creatures of habits. We repeat our behaviors. But as this experiment shows, we have little a priori idea of what we'll like. So this is not to say you should all go out and order a liver and banana omelet this morning for breakfast, but it may serve as motivation to try something new on a regular basis. Thank you.
All right. Hello, my name is Micah Eckhart. I'm a member of the Affective Computing Group at MIT at the Media Lab. And I'm really excited to be here, first of all, amongst so many talented people. And I know that many of you are also business leaders. And I've actually been thinking a lot about business. And being a student at the Media Lab has broadened my understanding of the boundaries and interaction between business and academia. And it's really changed the way that I'm going about my own work and thinking about the problems that I'm approaching. And this is important because I don't just want to do good research and end up with some journal papers or a great demo. I really want to help as many people as I can, as soon as I can. And this really changes the way that I approach the problems that I'm approaching. And so the reason that this is important is because I'm trying to develop assistive and learning technologies for children with autism. The air is so thin in Aspen. Does anybody have one of those air cans? And so there's a real need for these technologies right now for this population. And so autism is a condition that affects about 1 in every 110 persons. It's characterized by impairments in social emotional interaction, communication, and repetitive and restricted behaviors and interests. And there's a saying in the autism community that if you've met one person with autism, you've met one person with autism. And this relates to the heterogeneous nature of autism. It's very in the way it expresses itself. It's very unique in its expression. And when we think about autism, we need to think not just about the individual, but about the family, the friends, and the broader community that it also affects. And so my own research is focused on assistive and learning technologies for the acquisition and expression of language. And this is really important because language is a cornerstone of our ability to understand social emotional dynamics and for communication. And again, when we think about this, it's not just about the individual that has an impairment. It's about the family, friends, teachers, and therapists that it also affects. And it's important to consider these people and consider them in the solution because they're part of the solution. And so what do we know so far? We know that autism affects millions of people, it's highly heterogeneous, and it's social in nature. And so this tells us a lot. Unfortunately, it tells us there's no one solution. And any solution must account for the social nature of autism. That's both the impairment, but it's also in facilitating the support system around the individual to maintain a solution. And so this can be discouraging, all right? There's no one solution. You got to account for all these people, and you start to get an understanding for why this is a big problem and perhaps why there hasn't been more progress in this field. But I'm not discouraged at all. I'm actually really excited because I think there's new opportunities that are going to allow us to address this community in significant ways. And the reason I'm excited is because there's a certain classes of technologies that lend themselves to the creation of an ecosystem of solutions. Not one solution, but many solutions. And advancements that have been made in web and mobile technologies are allowing us to address the particular needs of the autism community in really exciting ways. But to do this, and I think that we have an opportunity to create a social platform that takes advantage of digital information to really empower this community. But to do so, you need to design in the features and flexibility to allow you to meet those goals. And so I'm developing a platform that allows for ubiquity and connecting with people, creating, sharing, and remixing content and media, personalization, the collection of data, personal and collective analytics, and openness. And this is important because I want people to be able to hopefully take my work, modify it, and extend it. And this is a big problem, and so we need to allow other people to contribute to the solutions. And so the thing is, by creating this platform, you actually allow yourself to create new types of applications that take advantage of the underlying structure of the platform. And so the first application I'm developing to take advantage of this system is something that I call Storyscape, a social illustrated primer. And so illustrated stories are actually a very powerful teaching tool, and they're currently used by teachers and parents and therapists for teaching language, for teaching social and emotional dynamics. And I know a lot of these people, I've been working with them, and all too often for them right now, high tech means laminated paper and Velcro. And if anybody's familiar with this community, you know that's true. And so Storyscape's going to go far beyond that. It's going to allow parents and teachers and therapists to create their own stories, but to also share those stories with a broader community. And they can also take the story of someone else and remix it to fit their particular needs or their child's particular needs. But what I'm really excited about also is that this becomes a creative platform for individuals on the spectrum to express themselves in new and creative ways. But it's not just about creating stories, it's about how we interact with stories and how we ultimately interact with language. And so I'm developing into this application a rich set of interactions between the user and the story, because we want to engage the individual in this language-centric activity, and we want to allow them to explore language in different ways. Storyscape is also going to allow you to combine your world with the story world. And this is a really powerful feature because, as I mentioned earlier, many individuals on the spectrum have restricted interest. And this is where they may be, extremely interested or motivated by a particular item or topic. And so now this is going to allow them to easily mix that motivator into this language-centric activity to engage them in this process of language. In addition, we can create stories that have particular learning outcomes. And now the child can take that story, they can interact with it anywhere, anytime, and the data about that interaction can be collected. It can be provided back to the individual, the parents, the teachers, the therapists, to inform them about the child's ability and progress so that they can work together to really facilitate the potential of this child. So this is the work that I'm currently developing. This is what I'm working on. I'm really excited about it, and I think that we're going to make a lot of positive impact for this community. But like anything, there's no guarantees. There's a lot of risk in stepping out and trying to do something no one else is doing and going about it. But you can improve your chances significantly by surrounding yourself with great mentors and collaborators. And I definitely invite anybody here to be one of those. And I look forward to talking to you about any part of this project. Thank you.
Good morning, I'm Dan Macduff. I'm also in the Effective Computing group, and I'm going to talk to you more about stories and how we can understand the impact of stories that we're told. And I'm going to do that through hopefully explaining how we can understand the emotional impact of stories and how we can use technology to measure how people respond emotionally to content. So stories are
Hello. Hey, what's up? Nothing big. Just watching the game.
They're in movies, they're in politics, education, advertising. We see them everywhere. People are interested in telling us stories, and many people are interested in consuming stories. Interesting statistic from Google that 48 hours of content is uploaded to YouTube every minute. It's a huge amount of unique content that is created by people around the world. It's becoming very democratized. Storytelling is no longer confined to people who are in charge of network TV stations, but there are people creating information about specific things they're interested in. They're creating content that they wish to use to help persuade people about things that they're passionate about. But really understanding how effective this content is a big problem. And I'm sure that if you ask anyone involved in advertising in particular, how much they're aware of the effectiveness of every dollar they spend, they'll probably tell you it's very small. There's a famous quote that says 50% of the money spent in advertising is successful, but it's unclear which 50%. And so that's a lot of wastage. And how can we use emotions and people's emotional reactions to stories to better understand what makes an effective story? And that's what I'm going to talk about, and I'm going to talk about some new technologies we're using, new frameworks that we're deploying over the web to measure people's reactions to content. And in order to measure emotions, we can think about it in a fairly simple way by thinking about how excited does a particular experience make someone. So that can be thought of as arousal. And then valence tells us about whether that's a positive or negative experience. And I'm going to talk about different technologies and how they can help us measure each of those axes. But what's important is that we can do this over a large scale. In the past, measuring reactions of people has been confined to in the lab. We've brought people into a foreign environment, we've shown them content, and we've asked them to report how they liked it. And that's a very unusual experience. It's not like the experience of normal consumption, which might happen in the home, out in the wild. So I'm using a web-based framework, allowing people to access the content online and using ubiquitous technology like webcams, so sensors that are around everywhere, in order to measure people's reactions to that content. And obviously, as Ben mentioned, there's a lot of privacy issues with this, and we frame it very much as an opt-in solution. We want people to be aware of the technology. We want them to be aware of their vote by using this technology, and how the technology can be used to hopefully improve the stories that we tell, our understanding of how we can be more persuasive and we can achieve our aims. So here's some examples of people's reactions to a particular Super Bowl commercial that we've measured over the web. And you'll see that they're very natural, they're spontaneous, and they're very varied, even though the people know that their webcam is turned on. So I'm going to stop it there, and I'll show you some more data of the aggregate responses of people. But as you can see, we have very little control over the lighting, the conditions, the motion of people, the general behavior that they exhibit while they watch these commercials. So how can we use this noisy data and use computers to automatically analyze some of the gestures they're making, the facial expressions, and behaviors they're showing, in order to extract useful information? Well, the development of facial expression analysis has been great over the last 10 years. And we're now at a stage where we can take this type of data and we can automatically analyze how much someone is smiling, whether they're frowning during a video, a particular point within a clip. Here we show just one example of someone's response, how much they're smiling during a particular piece of content. And obviously, there's great individual difference in terms of people's responses. Many people will respond in different ways because they some people will like a particular thing, some people will dislike it, some people will be confused and not understand perhaps the joke that's being made, other things. So understanding this data on a population level, on a larger scale, understanding the differences between people in different geographic locations, age groups, genders, is important. Here's, I'm going to show you some results showing how the aggregate responses of people watching the Darth Vader commercial change as they watch it for the second, third, fourth, fifth time. And you'll actually see that the mean smile response increases for those people watching it for multiple times, and actually their response becomes faster. They begin to anticipate the jokes that are coming, and we can start to understand how people's behavior and response to a particular piece of media changes over time. Oh, sorry. And we can see that actually what's interesting about that particular commercial was that it went viral. It had a huge number of views. This is just the number of views that it had on YouTube, 53 million. That's not counting all of the times it was seen on television, seen during the Super Bowl. And the characteristic of content which improves as we, the response increases every time it's watched, might tell us about what makes a particular video viral, what makes people remember information about it, what persuades people about the message that is contained. Another technology is technology that we're developing to actually measure physiological information based purely on video information. So using the webcam signal that we can collect the RGB information to measure people's physiology, not just their facial expressions. Here's an example of our algorithm in action, measuring the heart rates of these people just purely from the video signal, and we're comparing to a contact sensor which might traditionally be used. But by combining this multimodal information, so physiological responses, facial expressions, gestures, we can hopefully understand the links between emotion and what makes the story likable, what makes it memorable, what makes it persuasive. And now that we have distributed systems over the web, education is becoming often very popular online, so the Khan Academy, TED, distributing information online, but understanding how effective that is over a large population is a very open question, and that's what I'm exploring in my PhD thesis, and I'd be very happy to talk to you about more specific results afterwards. Thank you very much.
Things in my hands. We like to break demos at the Media Lab. Just turns out that this time I have way too many things in my hands. All right, there we go. All right, so I'm happy to be here to talk to everyone about the biomechatronics group and some of the things that we're working on. Obviously, one of the things I brought up is a robotic ankle, but in general, what I'm going to be talking about is how the notion of disability is actually changing in the world. So, a little while ago, there was a South African runner named Oscar Pistorius. I don't know how many people have actually heard of him, but yeah, there we go. So he's actually a pretty incredible guy, and I was lucky to have the chance to actually meet him while I was at MIT. And he's just an incredible, physical specimen of, athleticism. A little while ago, the Olympic Committee actually didn't let him into the Olympic qualifiers, of course, because he has these prostheses on. They're a conventional prosthesis. They don't have a motor on them. They're carbon fiber. They're called cheetah legs. So the interesting thing there is that he's actually not getting a metabolic or a mechanical advantage from wearing these, but he still is just like, he's just a killer performer. And so when you see him run, you're just like, man, I can't run like that. I don't know if anyone in here can actually run like that. I mean, I know there's some Olympians here, but I don't know if they're in this room. But anyways, calling this man, oh, all right, yeah. But, the thing is, calling this man disabled is really just kind of weird when he can run so well. And so we really think that the notion of disability is starting to change because of all the technological progress we're having. So biomechatronics really is roughly just a combination of biomechanics and mechatronics, two kind of independent fields. And biomechanics is sort of one part of our lab where we do all the clinical studies, we do all our research, and then rehabilitation and augmentation is actually when we go out and build the thing and put it on people. So for example, that ankle over there. We do a lot of motion capture. Those of you that work in the movie community know about this stuff. And we're all about capturing as much information as we can about sort of the biology. You know, people walking around, people running, things like that. The other thing that we're doing, which I think is really exciting, I'm a PhD student in this group working on data mining, machine learning, applied to neural signals. So we're trying to get a really deep measurement of neuromuscular activity. And what's really cool there is that we can actually regrow nerve tissue into the muscle and then apply it to a robotic ankle. So what's the result of all this? You know, at the end of the day, we want to take this science, we want to do something with it, we want to build something, we want to get it on people and get them using it. So we've got something like that. We've got a robotic ankle, we've got other robotic devices, and what's really interesting here is that anyone can really use it. It attaches itself to a socket, like you'd expect. This is Hugh Hare, who's the PI of my group. He's a bilateral amputee. He lost his legs in a mountain climbing accident from frostbite in Mount Washington. But a truly amazing guy. Can pretty much kick my butt at anything athletic at this point, but you know. But if you look at him walk, I don't know if you guys can tell, but I can't tell that he's an amputee. If his legs weren't passing up, you wouldn't be able to tell the difference. You know, and so when he's walking, you know, you notice he's got what we call the 9 determinants of gait. And what's interesting here is this ankle can be put on someone, and within hours they're walking, you know, and they're just comfortable with it. It's as natural as you could be. So as you can see, you could go through and handle a lot of different terrains. You can handle ramps. Start walking downstairs, sort of point his toe. And this is just the beginning, so we're going to see a lot more terrains. And part of my PhD research is to explore those different terrains. Actually, I want him to get into salsa dance at some point. He asked me to do that one time. I was like, Hugh, why do you want to do that? He's like, you know, man's got to dance. But you know, the other thing is that if you look at the metabolic economy with which he's walking, if you look at the non-amputee empowered prosthesis all the way on the right on that bar graph, their per velocity and everything, the metabolic economy is actually pretty close to an able-bodied walker. So that means they're not working harder to walk anymore, or they're not doing a lot, you know, they're pretty much on par with you or I, you know, with intact limbs. And this is just the beginning, so we want to go way past there. We want to move up the legs, so we're building robotic knees. We're also building running prostheses, again, because he was like, you know, I want to run a marathon. And this would not be allowed in the Olympics, by the way. It's got 2 motors on it. And what it's going to do, what it does is actually, we tried it on him, it winds up the leg, compresses it, acts like a spring, and gets him to run a little bit faster. So again, that's not going in the Olympics. The other thing is actually we're interested in working with everyone. You know, everyone can be augmented a little bit. But we don't want exoskeletons that look like this necessarily. I mean, they're kind of cool, but, you know, it's going to run into doorways. You know, it's going to have a problem. So instead, we're looking at lighter structures, things that you can carry around with you. The U.S. Army actually gave us a grant a while ago to do load carrying. So 300-pound backpacks are a real pain in the butt. And you got to walk for a long time with them. So we built an exoskeleton to try and make that a lot easier. So hopping is something we studied because running is similar to hopping. We were able to get an augmentation there. So I've got a video with a little bit of Vangelis. I think it's Vangelis at the end, but you'll see. Of a running exoskeleton. This is one of our MIT undergrads who works with us who, God bless him, was willing to strap on this exoskeleton on his body. So we were really happy when it worked, you know. This is really good. So what it's doing is actually, it's forcing him to hop when he lands. And when he kicks out his leg, there's a clutch that engages and allows him to improve his metabolic transport while running. It's close. It's getting there. Yeah, I know, right? I love Vangelis. All right. So the final thing I wanted to talk about is that we're working on developing world prosthetics. So I've been teaching a class at MIT for about 3 years. We had teams of undergrads come to work on a lot of different projects ranging from knees, ankles, other things. And you know, I said, why the hell do we have these people, you know, smart people redesigning products and not like commercializing them? Why not bring them out into the world? You know, get people to, you know, start using them in the wild. So out of 60 students, I felt like maybe 5, you know, which is a pretty good return, were really good. And we decided to start a nonprofit to spin out some of the projects. Here's one of them. It's a new exo knee prosthesis designed by Ken Endo in my lab. and it fixes a lot of problems with stability of walking in amputees in the developing world. So we're working on a co-creation process in collaboration with IDEO, and hopefully we should be able to help out with some of the infrastructure there. So just the big picture is that we just take science, you know, looking at science, but you have to go beyond the science. You've got to look at how you're going to make this an assistive technology and really add value. And we really do just want to, you know, transform what people actually, you know, mean by disability and realize that disability doesn't exist the way you think it does anymore. So it takes the work of a lot of people, and cheers to them. Thanks. Yep.
All right, hi everyone. I'm Nadia Peak. I'm in the Center for Bits and Atoms. And in the Center for Bits and Atoms, we work at the intersection of the digital world and the physical world. You might be familiar with some of the things that came out of our lab, like e-ink, the display that's on Kindle, or RFID, radio frequency identification technology, or that really annoying beeping thing that beeps at you when you don't buckle your seatbelt. Sorry about that. And to be able to make all of these different devices and the different things that we make in our lab, we have probably $20 million worth of equipment, of manufacturing equipment that was funded by NSF, DARPA, basically you guys that pay taxes. And whenever you take lots of taxpayer money, they want to know what you're doing with it, which we weren't really sure how to explain because we didn't want to write an article for Scientific American because everyone knows MIT students don't know how to write. And we didn't want to do a museum exhibit because that seems like something that we wouldn't really be able to pull off either. So instead, we made this, we made a small subset of the machines that we have in our manufacturing facility, and about $50,000 worth of equipment, and put it in inner city Boston and called it a fabrication laboratory, or a fab lab. Ever since that first lab started, it has gone to lots of different places. There's 150 labs currently in the world. And in those labs, we have laser cutters, 3D printers, milling machines, a full electronics workbench so that you can work on open source hardware. We have lots of experts that then you can talk to who have access to the same machines you do to be able to make things. So there's one, for instance, in Jalalabad in Afghanistan. And I'm sure if you guys went to General McChrystal's talk yesterday, he knows much more about this, but there's a general lack of comms, especially in the civilian society. And so they decided to use the lab to make their own wireless antennas to be able to share internet throughout the city of Jalalabad so that they could have access to great things like MIT OpenCourseWare, MITx, and use that in the civilian population. The girl in the middle there, that's Valentina. She's in Ghana. She made a remote sensing server node. She's 8. I did that when I was an undergrad. It took a lot longer. So there's really a lot of technology here that you can use to leapfrog over what traditionally is seen as innovation that happens in extremely large corporations at a large scale. So last year, at some point, Obama visited a lot of different community colleges in the United States to understand capacity building in the STEM education. Right here, he's inspecting a wood routing CNC router at Lorain County Community College, where they have a fab lab. And I really think that this is spot on for understanding how innovation might develop as we continue along this digital fabrication route, because you don't need an economy of scale anymore. The Industrial Revolution gave us mass production. That was great when everybody wanted a black Model T. But now, really, you don't need to have that kind of startup capital to be able to make one-offs. So how can we harness this when students around the United States are trying to learn how to innovate? I think that digital fabrication is really key in that. And so, unfortunately, not everyone has access. You guys all have access to all these machines right now, because if you guys seen the Spark truck from Stanford's group, you can use any of the machines that I was showing here earlier in their truck, so it's more mobile. And in the fall, we teach a class at MIT called How to Make Almost Anything, and we're really not trying to be hubristic about it. We really think that you should be able to take a class and learn to use all of these tools and innovate with anything that you want to be able to affect in your community. Unfortunately, not everybody has access to these things, so we started looking at using digital fabrication tools to make more digital fabrication tools so that everybody can have access to them. So in the middle, you can see a milling machine that replaces a $5,000 milling machine and is $400 in parts. And I don't know if any of you guys were at the reception last night. No? We have, oh yeah, here I'll tell you about. These are the Fab Lab locations that are currently in, or that I currently know about, except we don't really regulate this at all. They pop up new ones all the time. Apparently there's one in Rifle, Colorado, that's 60 miles down the road that's just opening right now. I haven't even heard about it yet. So this is really expanding quickly. And it's $50,000 worth of equipment. You probably want a manager that you want to pay a certain amount of money. Depending where you are in the world, it could cost more or less to pay that person. But it's, and if you want to make your own machines, then you can look at much lower prices. But yeah, it's not necessarily a big capital investment. And I started getting tired of leaving the lab. So me and Alon Moyer, who was in a slide earlier that Joey showed, made this pop-up 3D printer. So it's actually kind of like the analogy of digital fabrication on the laptop scale. So I took this as my personal item when I flew here from Boston and carry on. And this is a 3D printer, a milling machine, a plotter, and a vinyl cutter. So I no longer have to stay in the basement of the lab. It's fantastic. Anyway, that's all. If you guys want to see any of these equipment, it will be at the block party later.
Okay. Hi, I'm Eric Rosenbaum, and I promise that I have a pretty good reason to be giving my talk in bare feet. It has to do with a live demo that I'm going to give at the end of the talk. So I know we're a little over time, so please stick with me for that. I'm going to need the slides, actually. Thanks. So I'll be talking about the Makey Makey project. It's an invention kit for everyone. So I'm part of a research group at the Media Lab called the Lifelong Kindergarten. We're inspired by the way people learn in kindergarten by expressing themselves, collaborating and sharing, but especially building and making things. It's something that we get to do all day long at the Media Lab, of course, and we want to bring that type of creative learning out into the world and give people experiences throughout their lives to learn through creative play and especially through making. So I'm going to show you this project, Makey Makey, with a little video. First, it will demonstrate some examples of what you can do with it. I need the audio, please. Thanks. So you plug a banana into the Makey Makey, and it works as a spacebar. Let's look up a Super Mario Brothers game that you can play with the arrow keys and the spacebar on your computer, and instead build a game controller out of Play-Doh, plug it into the Makey Makey, and now you can actually play Mario Brothers on your homemade game controller. What if we want to play Pac-Man instead? Well, you play that with the arrow keys, but here, just with regular graphite, regular piece of paper, we can draw by hand the game controller and then play by touching the hand-drawn game controller. Gets a little crazier here. We're filling some buckets with water. Look up the game Dance Dance Revolution, a dancing game that we can now play by jumping into the water. This was a lot of fun to film, as you can imagine. It's not just about games. You can make music, too. Here we're wiring up a flight of stairs to be a piano that you play with your feet. You can, of course, make a piano out of bananas, too, or a synthesizer out of people and babies. Here, we've got the cat sitting on a piece of foil, and as soon as it drinks the water, it presses the button on photo booth so that it takes a picture of itself. And, of course, we couldn't do this all without alphabet soup. Plug the noodles in, and you can literally type with your alphabet soup noodles. So that's a lot of fun, obviously. We're trying to get this idea out in the world. And here's a little bit more detail about the Makey Makey. That's the circuit board, the front of it. You just plug something in, like a banana, to where it says spacebar on the Makey Makey, and then it works as a spacebar, like you saw. You can plug in to the arrow keys, the spacebar, or the mouse button. On the back of the board, you can also get more keys from the keyboard. You can also control the mouse movement, and there's a more advanced way to use it as an Arduino. You don't have to do any programming or any electronics, no software to install. You just plug it in via USB, and it's ready to go. So we're really excited about this Makey Makey project, and we want to get it out in the world in a big way. We decided to try to raise some money using a website called Kickstarter. It's a crowdfunding site. We thought maybe we can raise $25,000 for the project. Sounds like a lot to me, as I'm a graduate student. We did pretty well. As you can see, we undershot a little bit. We raised over $500,000, and now we're going to get over 10,000 of these Makey kits out in the world, which is incredibly exciting. During the Kickstarter campaign, just recently, it was a 30-day campaign, we wanted to generate some excitement from people in coming up with ideas for what they might use it. So this is in the future. They don't have kits yet, but these are some ideas. And the winners of our contest, we had 300 entries, included this one, which is a slideshow controller for the entrant's little sister. She's going to have a party. She wants to show photos. She loves the trampoline. Now she can control her slideshow by jumping on the trampoline using the Makey. Another person has a pet bird that loves a particular piece of music. Now the bird will be able to control the music. This is an interesting one. It's a way to use the Makey as a sensor to measure your urination and gamify it too. I love being able to put this guy up on a slide in front of people. That's a naked mole rat. Don't worry, they're actually really small and harmless, but this entry came from a graduate student who studies them, had a complex sensor system that wasn't working very well, and he realized the Makey is going to be a way to very accurately track where they are and what they're touching. Here's a twist on the game Twister to make it 3D. And finally, this one is a really powerful story for me. The entry came from a parent of a child with cerebral palsy, so this is something that limits the fine motor movement of the kid. But on one hand, there is enough control to play video games with the right controller, and that's something now that parent can make themselves using the Makey. And this is interesting to me because it points to a much larger area of ways that people will be able to use Makey for assistive technology to highly customize the solution just for that individual person, because as we know, disabilities are very heterogeneous. So now I'd like to invite up a few of my fellow graduate students, and I'm going to ask them to take off their shoes, if they don't mind, as well, and I'm going to show you how this thing works in real life. So I'm just going to grab this here. Actually, is there a third person that's willing to be barefoot with me? So what I'm going to show you is the human synthesizer. I'm going to need the audio from the laptop for this. Thank you. Okay, so they're just going to grab the metal tips of those alligator clips, and I'm connected to earth or ground. Now, if you could each hold up a hand, we're going to make a human drum kit. So ready? Here we go. Oh, man. I just need the audio from the computer. There we go. Thank you. Hey! Thank you. Take a bow. Take a bow. So just one last thing. You can find more about Makey at makeymakey.com, and please visit us there. So thank you very much.